Hi, my name is Joseph Laurel, and this is my Pokemon type classification project. So what are Pokemon? Well, Pokemon collectively refers to all 889 species of fictional creatures from the franchise of the same name. So the important thing about Pokemon types is that there's 18 different Pokemon types with their different strengths and weaknesses, and that Pokemon can have up to 2 types. And this is important because it allows your attacks to be 2 times effective if you have a type advantage. So as you can see on the diagram on the right, fire beats grass, grass beats water, etc. So here's an example, one example of every type of Pokemon. You can see that there's 18 and that they have distinct features that make them very unique as a type. So the goal of our project is to use a model to determine the type of Pokemon from an image. And then can we use this model to alert a user of the opposing Pokemon poses a threat and then suggest a counter using neural networks. So the data is hosted on PokemonDB.net. There's around 900 Pokemon total. 8,000 colored images were scraped off of the website, and their names and labels were also scraped off of the website used to create a data frame. And then most of these images were 128 by 128. A select few were of differing sizes. So if you look at the distribution of the actual classes of the Pokemon, you can see that the water types are the most prevalent, while the ice types are the least common. If you look at the actual distribution of the images, the water types are still the most prevalent and the ice types are still the least common, but certain types like flying type get a significant boost just by the amount of images. So when we look at the data processing pipeline, we use a train test split to split the images into training, testing, and validation set. These were done with the same random state and a 20% split, and the class weights were considered during training. So why do we use precision recall? Well, high precision will help us determine whether or not our alerts are actually correct. And high recall will help determine whether we should alert when a threat is present. So recall is actually very vital because in Pokemon, failing to switch out when there is a threat can result in your Pokemon fainting, and reviving Pokemon can cost real life currency to Pokemon Go players. So when we look at the basic neural network structure, we can see that our model consists of 4 convolutional layers with dropout and 3 dense layers. When we look at the transfer learning structure, we utilize the Inception v3 and Xception models in order to have a pre-trained model. And then the output layer was pretty much the same thing as the basic CNN structure. It was 2 dense layers and 1 activation layer. Our precision recall threshold was 0.4. Our optimizer was Atom with a 0.001 learning rate, and we used binary cross entropy and sigmoid activation function. So when we look at the model results, we can see that the baseline was around 12% recall, which is what we're looking at. But we can see that with the basic CNN model, our recall jumps to almost 50%. And with Inception and Xception, it goes even higher. You can see that this is done in also a shorter amount of epochs, meaning that compared to the basic CNN model, Xception not only performed better, but also learns faster. When we look at the basic CNN results, you can see that versus the training data, the testing data has very low recall, almost half. This suggests that our model is clearly overfit. But when we look at the Xception model results, we can see that after 30 epochs, the training data and testing data both perform very well. So when we look at individual class recall, we can see that ground types struggle the most and flying types have the highest recall, meaning that our model classifies them most accurately. When we look at model comparisons, this is a grass poison type Pokemon. We can see that the basic CNN can't even recognize it. Inception can recognize it, and Xception recognizes it with even more confidence than Inception does. When we look at another example of normal and fire, we can see that the basic CNN does classify one of these types correctly. Inception classifies one of the types very confidently and correctly, but can't seem to identify the other one, while Xception identifies both very confidently and correct. So when we look at the Flask WebApp, we basically take a user image as input, and we obtain predictions from the model. We find the counters based on the types predicted, and we display image and types of the top 5 counters. And then additional steps we can take is training with more images of Pokemon that aren't as clean from different angles, looking into creating an ROC curve by adjusting threshold, and improve our application by considering the user's Pokemon so we can actually simulate matchups. Then we can go to the web app, just a quick demonstration. So what we'll do is we'll pick a file. This is a fire type very clearly. And then we'll hit submit. And then it not only will print out the predictions, but it will also print out the top 5 counters. So you can see here that it correctly predicted it as a fire type. See that because fire has a ground type weakness, rock type weakness, water type weakness, that it correctly suggests counters. And thank you for coming to my presentation, and any questions.